Artificial intelligence is all around us now. It helps us find our way across town, choose what to watch or read, and support the familiar technologies woven into modern life. It has been quietly incorporated into the fabric of the everyday, often working behind the scenes, silently and tirelessly. But AI did not emerge overnight. It has a story, one built from imagination, math, ambition, and the human desire to understand intelligence itself. And that story begins long before the first computer ever blinked to life. For centuries, people imagined artificial beings. Ancient myths told of talking statues and mechanical servants. Early inventors built automata powered by gears and springs. These were not intelligent by modern standards, but they revealed something important. Humans have always been fascinated by the idea of creating thought outside themselves. That dream lingered quietly for ages. It would take the invention of electronic computers in the 1940s to give it a place to grow. In 1943, Warren McCulloch and Walter Pitts released a paper that introduced a remarkable idea. They described a simple mathematical model of a neuron. It was not a biological replica, but more like an on-off switch. When many were connected together, their system could imitate patterns of logic. This planted an early seed. Perhaps intelligence could be understood and even recreated in terms of networks and patterns. A few years later, in 1950, Alan Turing asked a bold question. Can machines think? He suggested a simple test. Hold a text conversation with a machine. If the person cannot reliably tell whether it is human or not, then the machine has demonstrated something like intelligence. This idea became known as the Turing test. The official birth of AI came in the summer of 1956, during the Dartmouth Summer Research Project on Artificial Intelligence. In their proposal, the organizers made a remarkable claim. They said that every aspect of learning or intelligence could, in principle, be described clearly enough for a machine to simulate. It was confident and ambitious, and it set the tone for everything that followed. From that moment, artificial intelligence was no longer just a dream. It became a discipline. The late 1950s and 1960s were full of optimism. Frank Rosenblatt's perceptron, an early learning machine, could recognize simple shapes. Programs were written that could play checkers, solve equations, and prove mathematical theorems. In the mid-1960s, a program called ELIZA simulated a conversation by rephrasing what people typed. It did not truly understand anything, but it felt surprisingly lifelike at the time. Some researchers believed human-level AI was only a couple of decades away. Time soon proved otherwise. By the 1970s, progress slowed. Early systems worked well on small problems, but real life was messy. Computers struggled with the complexity of the real world. Funding faded. Enthusiasm cooled. This became known as the first AI winter. Yet progress continued in other ways. Researchers developed expert systems, which encoded the knowledge of human specialists using large sets of rules. These systems found use in medicine and industry. They were helpful, but rigid. They could not learn on their own. A second AI winter arrived in the late 1980s and early 1990s, when even expert systems ran into limitations. But an older idea was waiting to return. Instead of programming every rule by hand, what if machines could learn from examples? This idea gained momentum in the 1980s with advances in neural networks and a method called backpropagation. This allowed multi-layer networks to adjust their internal connections based on data. The concept was powerful, but computers were still not fast enough to unlock its full potential. The 2010s brought a turning point. Suddenly, the three ingredients neural networks needed arrived at the same time. Powerful hardware, especially GPUs, huge data sets from the digital world, and practical algorithms ready to use them. In 2012, a deep neural network called AlexNet won a major image recognition competition by a dramatic margin. It was a breakthrough that changed the field. Progress accelerated, speech recognition improved, language translation improved. AI systems became better at identifying faces, objects, and voices. In 2016, AlphaGo defeated one of the world's greatest Go players, a milestone many thought was years away. It showed that machines could discover strategies even experts did not see. In 2017, a new architecture appeared. It was called the Transformer, introduced in a paper titled "Attention is All You Need." This design changed how AI processed information, especially language. Transformers were excellent at understanding relationships within sequences, such as the meaning of a sentence or the structure of a paragraph. When trained on large amounts of text, they learned to summarize, translate, converse, answer questions, and generate new content with surprising fluency. It was not magic, but it often felt close. The success of Transformers did not stay limited to language. Soon, AI models were generating images from descriptions, composing music, helping write scripts, designing prototypes, and even assisting in scientific research. This new era, generative AI, is less about replacing creativity and more about amplifying it. These systems can brainstorm, draft, remix, and inspire. They provide possibilities that humans shape into something meaningful. Used thoughtfully, generative AI becomes a partner in creativity. Today, artificial intelligence is everywhere. It powers search engines, maps, translation tools, recommendation systems, fraud detection, creative software, and more. It helps doctors detect diseases earlier. It helps engineers explore safer designs. It helps teachers reach more students. AI is powerful but not perfect. It learns from data, and data often carries human imperfections. That is why AI still needs us, our judgment, our values, and our responsibility. Used well, AI does not replace human thinking. It strengthens it. Looking back, the history of AI shows us more than the evolution of machines. It shows us the evolution of human curiosity. From ancient automata to modern neural networks, each chapter reflects the same impulse: the desire to understand intelligence and extend our own abilities. The question ahead is not just what will AI become, it is also what will we become while using it. If we choose curiosity over fear, wisdom over haste, and responsibility over convenience, then AI can remain what it is at its best: a tool shaped by human hands meant to improve human life. From early ideas etched on paper to systems shaping the modern world, the journey continues. You're always welcome here. And remember, it's Illumentary, my dear viewer.